faithfully delivering value by interpreting great books from around the world.
Hi, this is Sally with the Book Talk.
Today, I'll be interpreting the book titled Descartes' Error for you. The subtitle is Emotion, Reason, and the Human Brain. The author is Antonio Damasio, an American neuroscientist and neurobiologist. He's a professor of neuroscience, psychology, and philosophy at the University of Southern California and a member of the American Academy of Arts and Sciences. Damasio has been dedicated to neuroscience research and achieved significant results. His research is frequently cited by scholars across disciplines, earning him the title of a highly cited researcher in the U.S. The Descartes error we're covering today is his most famous work. People seeing this book title for the first time might feel a bit confused. Descartes was a renowned 17th century philosopher and scientist, hailed as the father of modern philosophy. He also created analytic geometry. Did the author use Descartes' error as the title just to grab attention? Or did Descartes actually make some mistake? We know Descartes championed mind-body dualism, meaning the human body and mind are completely separate. According to dualism, bodily functions like breathing, heartbeat, metabolism, foraging, evading predators, and reproduction are innate. But mental abilities such as analysis, reasoning, and decision-making are shaped by culture, education, and society, unrelated to the body, a view that fits common sense. For instance, you might have heard strong body, simple mind, and there are folks like Newton or Hawking who were physically frail but brilliant. The author disagrees with Descartes. He argues that cognitive activities depend on bodily functions, and this book aims to challenge dualism's biases. Now, I'll break it down into 3 parts for you. First, what insights did the author gain from studying Phineas Gage's brain? Second, why does emotion affect rational decision-making and reasoning? And third, where exactly did Descartes go wrong?
Let's start with part 1. What insights came from studying Gage's brain?
So who is Gage? He was a 25-year-old railroad construction worker in New England, USA. In the summer of 1848, to lay a railroad, workers needed to blast away numerous rocks blocking the path.
During an explosive setup, the powder accidentally ignited and the blast propelled a large iron rod upward.
The rod pierced Gage's left cheek, went through his skull, and flew out covered in blood and brain tissue.
Miraculously, Gage survived and could still speak, walk, and think normally.
However, this injury caused astonishing changes to his personality. Gage's temperament, preferences, even his dreams and ambitions all changed, as if he became a different person. Originally a highly capable and efficient foreman, he was quick-witted, kind, and courteous to others. But after the injury, Gage became rude, unrestrained, and vulgar. He stopped respecting colleagues, growing extremely impatient with any actions or suggestions against his will.
He made many plans, but often abandoned them before implementation.
Colleagues barely recognized him, and he became unfit for his job. Similar to Gage's case, other brain-injured patients retained intact intelligence or language skills, but abandoned learned social customs and ethical norms. Thus, scientists believe cases like Gage reveal a startling truth. Human personality and social abilities, like predicting behavioral outcomes, planning in complex social contexts, and taking responsibility, and may be controlled by specific brain regions, meaning social abilities are like motor skills, perception, or language, each potentially mapped to dedicated neural areas. Later cases further confirmed this conclusion. For example, the author encountered a patient named Elliot, once a good husband, father, stable worker, and role model to colleagues. In short, he had an enviable personality, career, and social standing. He developed severe headaches, was diagnosed with a brain tumor, and successfully had it surgically removed. But along with the tumor, the damaged frontal lobe tissue was also excised. Although after surgery, Elliot performed normally on intelligence tests and even passed personality tests with ease. But in many ways, Elliot was no longer himself. He showed almost no emotional expression, couldn't plan his time effectively, and his decision-making was full of flaws. For instance, when needing to shift work goals, he'd ignore priorities and stubbornly cling to previous tasks. Similarly, he could hardly make effective decisions or complete any tasks. All right, that covers the main points of part one. Through cases like Gage, the author shows social abilities such as reasoning and decision-making aren't just products of nurture but depend on specific brain regions, contrary to mainstream views. People struggle to accept that moral and cultural aspects defining humanity rely on brain structures rather than upbringing. But from an evolutionary survival perspective, this makes perfect sense. Mention bodily functions, and many assume they're purely innate instincts. For example, humans have innate neural circuits for breathing, heartbeat, metabolism, foraging, predator evasion, and reproduction. Unlearned yet adaptable. As individuals grow, life experiences continuously feed into these circuits. For optimal survival, this reshapes brain structure to mature and efficiently adapt to environments. Take self-awareness. Newborns don't recognize I, but as they develop, they grasp self-identity. Over time, they still recognize their mirror reflection. This shows neural circuits silently adapt to bodily changes brought by aging. So lived experiences continually reshape neural pathways, altering our innate nature. Thus, the author argues acquired abilities can embed into human evolution as innate functions. Now, studying patients like Gage and Elliot, the author also found they shared a peculiar neurological trait. This psychological phenomenon mainly involves emotional blunting and minimal mood fluctuations. Thus, the author proposed this view. Emotion is indispensable for rational behaviors like analysis, reasoning, and decision-making. At first glance, you might also struggle to accept that emotion relates to rationality. They seem like polar opposites, don't they? Mind-body dualism explicitly denies emotion's role in rational decisions, even viewing it as noise interfering with logic. So why does the author claim emotion affects rational decision-making and reasoning? That's our second key focus today. To answer this, we must first understand what emotion actually is. Take fear. Externally, it's racing heartbeat, shallow breathing, trembling lips, weak limbs, goosebumps, or gut churning.
Or anger. Burning chest, flushed face, widened eyes, clenched jaw, and fists ready to strike.
But these are just surface manifestations. Emotion fundamentally corresponds to specific bodily and brain systems, like vision involves eyes and visual cortex. The author further confirmed emotion-brain links through experiments. He tested patients with relevant brain damage alongside neurotypical individuals, measuring physiological differences using a highly detectable indicator, skin conductance response. When sensations or thoughts affect us, the autonomic nervous system increases sweat gland activity. This method easily detects psychological fluctuations in subjects. In the experiment, brain-damaged patients and neurotypical subjects viewed neutral landscapes, horror images, and ecstatic scenes. Frontal lobe damaged patients showed significantly reduced skin conductance changes versus neurotypical subjects. Some even reported feeling no internal reaction despite rationally recognizing the image's intensity.
This experiment conclusively proves emotion maps to specific brain regions.
The author divides emotions into two categories: primary emotions like basic happiness, anger, sorrow, and fear, simpler emotional types. The second type builds upon primary emotions, forming more complex and nuanced feelings, termed secondary emotions. It's these layered emotions that guide the body into reasoning processes. First, primary emotions. The author believes they're innate or acquired very early in life. For instance, when an eagle flies over a baby, it instinctively ducks without identifying the animal. The author argues we don't innately fear eagles. Rather, sensing specific stimuli, like large size, swift movement, sharp sounds, triggers pre-organized emotional responses. In other words, the baby doesn't know eagles are dangerous. It's reacting to a large winged object moving swiftly overhead. This fear triggers the ducking action. Here we see fear's two key traits: guiding rapid judgments and reactions and being consciously perceptible. Now, one might ask, if we have automatic reactions, why consciously perceive emotions?
In other words, why not keep this process automated in the background?
Because awareness heightens vigilance and broadens protection. We categorize knowledge and stay alert to similar looking threats, enhancing survival. Experiences from prolonged social living continuously feed into brain circuits. Thus, emotions become further differentiated. We consciously perceive not just primary emotions like sadness or anger, but also the secondary emotions they evoke. What are secondary emotions? They're more complex, nuanced emotions built upon primary ones. Take moral indignation. Not just anger, but outrage at injustice. Like primary emotions, they map to specific scenarios. But being finer grained, they match complex situations, enabling precise decisions. This intricate emotional landscape, it actually helps us evaluate and reason about events from more dimensions. These emotional reactions are acquired, not innate tendencies, forming unique personal experiences. In other words, different people may have different emotions toward the same scenario, and this personal experience automatically categorizes and labels external events as good or bad, often unconsciously, guiding actions like approach or avoidance. Now that we understand what emotion is and how it arises, let's explore how it promotes rational and efficient reasoning and decision making. This introduces the author's most famous finding, the somatic marker hypothesis. Ooh. So, what exactly is the somatic marker hypothesis, and why does it help people make decisions? We need to start with how somatic markers occur. Let's begin. Through long-term social life, our bodies assign different inclinations, good or bad, joyful or painful, to scenes we see, sounds we hear, smells we smell, building clear causal relationships. For instance, if something dangerous happens or if an action is noble. Later, when encountering similar scenarios, we may make judgments and decisions autonomously without rational thought. Take dodging a falling object. It's essentially a reasoning and decision-making process in practice. When you decide to dodge because it happens too suddenly, there's no time for judgment. Your body reacts before reasoning kicks in. This process doesn't even use explicit knowledge that can be consciously articulated or conscious reasoning strategies. As we grow older and gain more experience avoiding dangers, the brain establishes stable connections between stimuli and optimal responses. Our bodies have labeled falling objects as dangerous situations. Therefore, we can react spontaneously and quickly in similar situations without deliberate thought. You might say this decision-making process isn't what we typically call decision-making. All right, let's look at a more abstract decision-making process.
For example, suppose you own a large company and face a situation where meeting a client could bring huge benefits. But he happens to be your best friend's sworn enemy, and you must decide whether to proceed. You might rapidly construct scenarios in your mind.
For example, your friend discovers you're dealing with his enemy, endangering your friendship, or you cancel the meeting, losing huge potential profits, but preserving the precious friendship, etc. These scenarios consist of fleeting mental snapshots, not full sequential narratives. You'll notice the brain often makes sound decisions within seconds, something pure reasoning couldn't achieve. Actually, the process is this. Before rational analysis, something crucial happens. When negative outcomes surface, you instantly feel unpleasant bodily sensations. Since these sensations are body-linked, the author terms this phenomenon somatic states. As these phenomena mark representations, collectively they become somatic markers. Simply put, somatic markers act as efficient filters, directing attention to potential consequences, boosting decision accuracy. When a negative marker accompanies a future outcome, it serves as warning. Conversely, positive somatic markers paired with outcomes provide motivation. Most somatic markers in rational decisions come from education and socialization, as humans constantly absorb environmental influences. And while for instance, Our social environments, events, and customs create fixed causal links between behaviors and bodily sensations. Take helping others. This not only benefits recipients but rewards helpers with recognition, honor, fame, or wealth, pleasurable returns. The neural basis is somatic markers. Even without rewards, they prevent inner condemnation and shame. This interaction between internal preferences and external environments imprints numerous markers on the body. The critical period for accumulating somatic markers is childhood through adolescence, continuing lifelong. So accumulating somatic markers is essentially lifelong continuous learning. Somatic marking involves two mechanisms. Primary, the body forms somatic states guided by specific brain regions. In primary, the body forms somatic states guided by specific brain regions. So, this signal travels to the brain's somatosensory cortex, creating conscious awareness. Like when the amygdala accelerates blood flow, this bodily signal transmits to the brain and gets registered. We become consciously aware of our anger. In secondary mechanism, the body is bypassed. No blood flow causing blushing is needed. Instead of body-to-brain signaling, the amygdala directly connects with the somatosensory cortex. It's brain-to-brain communication, skipping the body and even consciousness, making it significantly faster. This mechanism allows the brain to predict outcomes before actual bodily signals return. Then it directly prompts specific actions occurring below consciousness. This process remains hidden from our awareness. This hidden process is the wellspring of intuition. We solve problems using this covert mechanism without engaging reasoning. So how do emotion-linked somatic markers enable reasoning decisions? Recall Elliot. Icy roads caused accidents during his clinic commute. He calmly described the accidents to his doctor and analyzed safe driving strategies for freezing rain. Here, he appeared supremely rational and composed. Yet, when scheduling his next appointment, his damaged emotion centers left him indecisive, endlessly comparing date pros and cons. Why? Because decision-making floods us with infinite information, demanding attention, past experiences, knowledge, behavioral outcomes, etc. Such information abundance requires prioritization. Here, somatic markers provide sorting criteria, expressing accumulated preferences we've acquired. How exactly do somatic markers establish this sorting standard? When different somatic markers coexist with various representations, they alter how the brain processes them, operating as preferences. These preferences allocate different attention levels to content, automatically creating an uneven cognitive landscape. Say I plan to collaborate with Company A for substantial profits. But learning Company A's head is my best friend's enemy. My somatic markers focus attention on our friendship instead. Not the immediate financial game. This subconsciously guides my decision.
With Elliot's damaged brain regions lacking emotional functions, he couldn't prioritize information.
Externally, this manifested as chronic indecision between choices. In decision experiments, frontal lobe patients couldn't learn from failures or see beyond immediate results. Blind to future consequences, they kept making poor choices. For example, the author conducted gambling experiments with patients. In clear win-lose scenarios, they failed to learn from losses and make sound judgments. This shows brain damage destroyed both existing behavioral knowledge and the ability to acquire new insights. All right, let's summarize part 2. The author detailed how emotion, a neural function, operates in rational reasoning through his somatic marker hypothesis. Analyzing emotion reasoning links explains our rapid reactions without deep thought and intuition's mechanics. Highly relevant insights. With life's overwhelming choices, we must leverage emotional responses for decisions.
Finally, part 3. Using cases and theories discussed, the author refutes Descartes' mind-body dualism, pinpointing his errors.
Descartes' dualism carves a gap between body and mind. One side is tangible, mechanical, infinitely divisible. The other is intangible, untouchable, and indivisible. He believed that analytical judgments, reasoning, and moral judgments exist outside the body. Specifically, he separated the most refined mental processes from biological organisms' structure and function, even referencing the philosophical brain in a vat idea. Well, the experiment suggests if a brain is removed, placed in nutrient fluid, and stimulated like in the real world, it would still have normal mental experiences.
But from the somatic marker hypothesis and evolutionary evidence, mind can't arise without a body.
Why do we say that? Let's look at an example. Late at night, you're walking home alone and suddenly notice someone following you from a distance. We usually say the brain detects danger, thinks up options, makes a choice, and then acts. In this view, rational thinking and judgment come from the brain, which then commands the body to act. But actually, in this scenario, the first thing isn't rational thought. It's a somatic marker linking the follower phenomenon to fear of danger. The brain first undergoes neural and chemical changes, causing massive shifts in tissues and organs throughout the body, like scalp tingling or heart racing. Then, signals of bodily changes return through neural circuits and chemical pathways in the blood. As we see in this real decision-making process, both body and brain constantly interact with the environment, adapting to make self-beneficial responses, meaning mind and body aren't separate. On the contrary, they're always closely collaborating and communicating, which makes perfect sense. If ensuring bodily survival is the brain's primary evolutionary goal, then when minds emerged, they focused on the body first to ensure efficient survival, naturally providing a high-efficiency solution. That is, when organisms interact with the environment, it changes the brain via neural circuits, ultimately building stable links between external surroundings and bodily functions through emotions. Um, well, Descartes has a famous saying, "I think, therefore I am," meaning that my body might be an illusion, but as long as I'm thinking, I can be sure there's a me thinking and confirming my existence. This view puts rational thinking on a high pedestal, even suggesting that only with rational thought can we prove our existence. But the author believes that in reality, life existed long before humans appeared. At some point in evolution, a basic consciousness emerged. With this basic consciousness, a simple mind was created. As the mind's complexity grew, the possibility of thought increased, making communication and organizing thoughts through language possible. For us back then, existence came before thought. Now, when we enter this world, we exist first and then we think. We can only think after we exist, because thought is triggered by biological structures and functions. The body and mind can't be separated. Descartes' error misleads people in many ways. At the scientific research level, some neuroscientists still hold remnants of Cartesian dualism in their thinking. They insist that studying thought only requires focusing on the brain, ignoring the rest of the organism, or the surrounding environment. In fact, they overlook that part of the environment is a result of human transformation and a product of mental activity. In practical life, various versions of Descartes' error lead people to ignore that the human mind is rooted in a complex, fragile, limited yet unique body, making it easier to overlook psychological issues from the body or reject treatments targeting biochemical reactions. For example, when it comes to depression, many people think patients only need psychological counseling or happy activities without medication and may even resist drug treatment. Actually, directly using meds to change brain chemical levels for emotions is an effective way to treat mental illnesses like depression. Another example, people often demand that those in key positions who make big decisions should ditch emotions entirely to achieve pure rationality. But if you know emotions and rationality aren't totally opposed, it's clear these decision makers shouldn't abandon emotions completely. Now, on the contrary, without emotions, it can lead to errors or inefficiency in decision making. Mind and rationality are indeed humanity's most precious treasures. But if you realize that such noble mind and rationality are inseparable from the body, and so are their origins and development, one, it's under such humble and fragile conditions, can we still acknowledge the importance of mind and rationality? The author believes that understanding these facts doesn't diminish the value of mind and rationality. Instead, it helps us recognize our own complexity and uniqueness more profoundly. A human mind that integrates body, brain, and interacts highly with the surrounding environment is even more exquisite. All right, that concludes our interpretation of Descartes' error for you. Book notes are below the audio. See you tomorrow.